Okay, so we've talked about the exponents. Now we're kind of doing like the reverse of that, kind of putting them together as we go into next week. But we're talking about simplifying square roots. So, like, what's the square root of 25? 5. Square root of 100? 10. All right, so we're kind of, instead of doing like 10 squared, we're looking at the square root. They're opposites of each other. So just today, I want to look at just how to simplify a single radical. Okay, next week we'll get into multiplying and dividing and all kinds of other stuff. All right, so if b squared equals a, then b is the blank of a. Square root. She said it over there, sorry. So it's a square root. So for example, 3 squared equals 9, and the square root of 9 is 3. Right? All right, so do you know what the symbol looks like for square root? Good. It's kind of like a little check mark with a little line over the top. That's referred to as a radical. So if you hear me say radical, I'm not living in the 80s. Everything's radical and gnarly. But that's what that thing is called. Okay, so here's an example kind of laid out for you, and then we'll go through some together so you can see how this works. Depending on where you've learned this, you may have learned it different ways. But to me, this is the easiest way for students to understand how to simplify a radical. Because in this classroom, I don't ever want to see decimals on anything. Okay? Never, ever, ever. We got that? Ramon, you got that? Yeah, no decimals, ever. Okay, so when we're simplifying like radical 24, that's not a perfect square, right? If you take the square root of 24, you don't get a nice, pretty answer. So we need to simplify it. So we're going to make factor trees. You guys know factor trees, right? So 24 is 2 times 12. 2 is highlighted. I always circle mine when I'm working through mine. I'm circling the 2 because it's prime, right? Only 1 times 2 gives me 2. So as once a number is broken down as far as it can go, circle it. Okay, so then 12, I can break down 2 times 6. 2 is prime. 6 is 2 times 3. 2 and 3 are both prime. So once you get the number broken down to all its primes, you want to look for pairs. Okay, pairs of numbers, so groups of 2. Right? And pairs, they go out. Think about it as going on a date, right? So you on a date, you're together, the 2 of you together go out on a date as 1, right? 1 couple. So when you look at this, I'm like, all right, I have a pair of 2's. This is how I typically work with these. I like to cross them off. So a pair of 2's will come outside as a single 2. Okay? A pair comes out as a single 2. And then the singles stay inside. So the singles, they stay in. I have a 2 and a 3. 2 times 3 is 6. So again, if you think about the dating concept, a pair of you come out together as 1 couple, you come out as a single. But if you're single, you stay in the house on the couch, eating pizza, ice cream, out of the whole tub, right? All by yourself. Yeah. That sounds kind of fun. It's not so bad. Yeah. Then you would take all the pairs out. Yeah, we'll look at some of those. All right, so let's go ahead and try one together. So again, I want to go through just 6 examples quickly, and then I'll turn you back on your own. So number 1, square root of 32. It's not perfect. Me personally, I always check to see if it's perfect right away. It's not. So what do you multiply to get 32? 8 and 4. It does not matter. She said 8 and 4. You could have said 2 and 16. It doesn't matter. Whichever way you want to split it, you're going to end up at the same spot, so it doesn't matter. All right, 8 can break down. What do you multiply to get 8? 4 and 2. I'm going to circle my 2 because that one's prime. The 4 can break down 2 and 2. Again, I'm going to circle my primes. Oh, I got another 4 sitting up here. 2 and 2. So you want to break it down till all you have are primes. Now, the only numbers I'm looking at trying to find pairs are my circled prime numbers. Okay, don't go back to this 4 and this 8 and this 4. I broke those down, so I'm not using those anymore. So what pairs do you have? Right, I got a pair of 2's, so they're going to come out together as a single 2. I have another pair of 2's. They also will come outside. And then this little single guy, he's on his own. He stays in his house all by himself. And then what's 2 times 2? 4 in radical 2. If you have a calculator in front of you, try try something for me. Type in the square root of 32. Tell me what you get. 5.6 something. Okay, type in 4 times radical 2. It's the same thing. Right? We're not changing the value of it, we're just simplifying it. Okay? So if you're unsure of, like, I don't know if I did that right or not, type it in the calculator. You should get the same decimal, your starting problem and the answer you got. So you can always check them to make sure it's right. All right, so let's try number 2. Is 54 a perfect square? No. Okay, so what do you multiply to get 54? 9 and 6. Right? 9 will break down. 3 and 3. 6 will break down. 3 and 2. Right, what do you have a pair of? Pair of 3s. I'm going to cross off that pair of 3s and a single 3, right? They come out together, single 3. And then I got 2 single guys. They're going to stay inside. 3 times 2 is 6. Pairs come out as a single entity. Singles stay inside together. Okay, how about number 3? Is 224 a perfect square? No. All right, what do you multiply to get 224? What'd you say? 28 and 8. I'll be honest with you, that would never have been my first guess. Me personally, if I'm doing this without a calculator, I looked at that and said 2 and 112. That would have been where I would have went. Doesn't matter though, you end up same spot. All right, so what about 28? 4 and 7. Oops, 7's prime. 4 is 2 and 2. 8 is 2 and 4. I'm going to circle that 2. And then 4, 2 and 2. All right, so I'm all the way down to just primes. Again, I'm just looking at my circled prime numbers. What pairs? Got pair of 2s, they come out. Another pair of 2s, they come out. Singles, good, radical, and then be 14, right? 7 times 2 goes in. What's 2 times 2? 4. Radical 14. Doing okay so far? Did she make you find the perfect squares? To be honest with you, that's how I do it. I do it in my head. But if you don't have a good basic knowledge of what your perfect squares are, it's hard. Yeah, this is what I found is the fastest, easiest way for students to do it. It's amazing how you'll get good at it. Like, you'll start to recognize the patterns to know where you're doing them. All right, so number 4, same idea. Did you notice there's a little person, there's already somebody outside, right? He stays outside. Leave him outside. Okay, let's just worry about what's inside. What do you multiply to get 48? 16 and, 6 and 8, you can go there. 6 and 8. Again, it doesn't matter if you want 2 and 24, 3 and 16, it doesn't matter. 6 is 2 and 3, those are both prime. 8, 2 and 4, no, 4, 2 and 2. Questions on how to do the factor trees? Okay there? All right, looking for pairs. Pair of 2s come out. Another pair of 2s that come out. A single 3, so radical 3. Is anybody else outside? Yeah, this 3 is already out here. Just don't leave him behind. All right, he's going to stay outside. Yeah, just don't leave him behind who's already outside waiting for you. Your friends are waiting for you. So 3 times 2, 6 times 2. So we have 12, radical 3. You're like, finally, something I get, right? Number 5. Ooh, there's a negative person outside. Does it change my process? No, same idea. All right, so what do you multiply to get 108? Oh, sorry, I heard 2 and 54 was the first thing I heard. Again, does it matter? No, doesn't matter. What about 54? 6 and 9. 6 and 2. 9. All right. Pairs. Pair of 3s. Pair of twos, they don't have to be right next to each other. I got two of them now. Singles. Put that single 3. He goes under the radical. And don't forget, you got that mean friend waiting out front. It's kind of negative. Comes down. Negative 5 times 3 times 2. Negative 30. Radical 3. Good. Good, good. All right, and number 6. 30 and 20. Interesting. To me, I hear 600. I would have split it 6 and 100. That's all right. 30 and 20. 30. 6 and 5. 6. 8 and 2. It's a great thing about math, though. It really doesn't matter. 20. 5 and 4. 4. All right. Pairs. Pair of twos. Pair of fives. Singles. 3 and 2. 6. And don't forget that one out front, the negative 4. So negative 4 times 2 times 5. Negative 40. Radical 6.